In this video, I introduce generative hierarchical RNN end-to-end dialog model. Suppose we have a dialog D that includes M sentences. Each sentence includes NM words or tokens. The goal of a generative dialog model is to predict the joint probability of the sentences from U1 to UM. That is equal to a product of conditional probabilities, where theta is a model parameters. This W is a word at a position N in the sentence M. This W is a previous words in the current sentence, and this U is previous sentences in dialog D. Recurrent neural network is a sequence-to-sequence model, which uses the embedded vector of each token Wn as the input, and his hidden state is updated in this formulation, where F is a nonlinear activation function. This last hidden state, Hn, can be viewed as all the sensitive compact summary of all the tokens. The hidden state Hn is used to predict the next token Wn plus 1 in the sentence. Namely, we use the input sequence as an input to the RNN module. And the input embedding matrix E encodes this one hard vector input to the distributed representation. And then I use the previous hidden state and the current input to update the current hidden state. And then we use output embedding matrix O operates on this hidden state to produce the input of a softmax function to generate the conditional probability distribution over words in the vocabulary. Here is a regular RNN encoder-decoder model. The encoder uses the input sequence as an input to generate the contact vector. And the decoder uses this contact vector as an input and uses previous output as an input to predict the next word here. Generative hierarchical RNN encoder-decoder model cascades the regular RNN encoder-decoder model together to generate hierarchical diagonal models. For example, inside each RNN encoder-decoder model, the encoder uses the input sequence as the input to generate this contact vector. And then I use this current contact vector as an input together with the previous contact hidden state to update the current contact hidden state. And then the decoder uses this contact hidden state as the input to predict the next word. And then we get this output sentence condition on this input sequence and the previous sentences. And then we use this output as the input sequence to the next encoder-decoder model. Finally, we generate a dialog D. For more details, please check with this reference. Thank you. Bye.